Hi all, welcome back to my channel. So in today's video, I'll show you how to set up jump and dash movement just like Hollow Knight for your player object by only using visual scripting and not writing a single line of code. So this is how your player jump and dash movement will look like after you have implemented all the steps or logic that I will be showing you guys in this video. Now let me show you the logic that I have included over here. For the wizard, I have created this script graph or script machine. I'll show you guys. There are various things that I'm performing in this script machine. Let's start with the start node. So for the start node, what I'm actually doing is I'm simply setting the dash time with the value of start dash time. So if you see over here, there's a variable called as start dash time. This one, the value is 0.1. So this is the time for which our player will be in the dash movement or dashing. So we are simply setting the value of dash time with the value of start dash time. We're also fetching the current gravity scale of our player object. This will be used for the dash movement because when the player is performing a dash movement, we do not want the player to fall down. So that's why we are simply fetching the current players or current objects dash or gravity scale. Now over here, we are simply checking what was the last direction the player object was facing, whether it was left or right. How we are checking? We are simply checking if A key was pressed. Then if it was pressed, we are simply setting the direction variable's value as -1 and also setting the local scale value to -1, 1 and 1. So this will flip the players towards the left direction. And if this is false, then again we are checking if D was pressed. If it is true, then we are setting the direction value to 1 and setting the local scale back to 1, 1 and 1. What will happen? If we'll go back, right now I'm moving to the right direction. As soon as I'll press A key on my keyboard, the player's orientation will be changed. So you see, now the player is moving or facing the left direction. I'll press D, player is facing the right direction. Now coming back, through this logic, we are simply setting the player's movement towards left or right direction. We are using fixed update method because we are performing the rigid body functions over here. So that's why we're using it. Now we are checking if the player is currently not dashing because we do not want our player to, perform the movement during the dash movement. If this is false, that means the player is not dashing, and we are simply setting the player's velocity in this way. We are getting the player or the keyboard's input like -1, 1 or 0. We are multiplying it with the move speed. So there's a variable called as move speed over here with the value 15. So it for the and over here we are simply creating a new vector too, and where for the x we are passing the multiplication factor of the horizontal values that we are getting as well as the move speed. For y we are simply fetching the velocity and simply passing it over here. This is the movement towards left and right. Now let's talk about jump. So again, for jumping we are first checking if the space key was pressed on a keyboard. Then we are checking if the player is currently dashing or not because we do not want our player to jump when the player is performing the dash movement. So that's why we are simply checking if this is false. Then what we are doing, we are simply setting our is grounded. We are simply checking if the player is on the ground or not because we do not want our player to jump in the air. So this logic is for that thing. If our player is currently on the ground or is grounded, we are simply setting the player's movement like this. So we are setting the player's velocity where we are simply fetching the x value, and for y we are passing the jump force. which is a variable, and its value is 70. So the player will be having a velocity of whatever is there for x, and for y it will be plus 70. So it will jump up. Over here, I am simply setting my Boolean parameters for my animation to kick in, and this is just a sound. That was about how to make a player jump up, but to make a player fall down or jump down, what I'm checking is if our pace key was released, then this section is there up. Then I'm checking whether the player's velocity in the y direction is greater than 0 or not. If it is greater than 0, then I'm simply setting the player's velocity in the y direction with the value of 0. So that as soon as we are releasing the space arrow key, our player's velocity will be in the y direction will be changed to 0. And this logic is for clamping the fall speed. So because we do not want our player to fall with the effect of gravity at all times, because what will happen if the player is falling from a higher ground? So until or till the time it reaches the ground, the velocity will be, impacted by the gravity scale as well. So that's why we are simply checking if our player's velocity in the y direction is less than the fall speed. The fall speed is again a variable over here. I've set it to minus 30. So you guys can make changes accordingly. So I'm simply checking if our player's velocity in the y direction is less than minus 30 or not. If it is less than minus 30, we are simply setting it back to minus 30. So the velocity will again have the y value of minus 30. So our player will constantly, if the player object is falling, it will have the constant velocity of minus 30 after a certain point. Now let's see how it works. Do you see? If I keep on holding my pace key, then the player will jump higher to the maximum height. And as soon as I release my jump or space key, our player will fall down. That's how I implemented the variable jump, just like Hollow Knight. And for falling down, so you see the player's movement in the negative y direction is clamped to minus 30 only. This logic is to check whether the player is on the ground or not. So over here, I'm simply checking if player has collided with the ground object. Then we are simply setting the is grounded value to true, and also setting these animation parameters. If our player is exiting the ground, that means our player has started jumping, then I'm simply setting the value of is grounded variable back to false. That's all for ground. Now let's move towards the dash movement. In dash logic, I am simply checking if left shift key was pressed. Then I'm setting the is dashing value to true. And then in the on update node, we are checking if is dashing is true or not. If it is true, then we are simply checking what's the value of dash time. If our dash time value is less than 0, that means the player should stop dashing. Then we are simply, making the player to stop dashing. So this is a subgraph that I created. I'll click on this. Over here, we are simply setting the is dashing value back to false because we want to stop the player from dashing. We are setting the dash time back to start dash time, that is this value, back to 0.1. We are setting the gravity scale of our player object back to whatever it was in the beginning. So if you remember in the start over here, we said whatever the value was there for gravity in this variable. So we are simply accessing this variable over here in a subgraph. So the value will be set to 20. And we are setting the velocity of our player object to 0 and 0 because we want to stop the dash movement. Now let's go back. Now if dash time is not less than 0, that means the player is currently in the dash movement. We are simply spawning particles. This is the logic for it. We are instantiating this particle system that I created as a prefab. I'm setting the position and the rotation for it in this way. Now after this, we are simply decreasing the value of dash time with the value of time dot delta time, and we are simply setting the gravity scale to 0 because we do not want our player to fall down when we are in the dash movement. So that's why we are simply setting it as 0, and then we are checking whether the player object is facing towards the left direction or the right direction. So for left direction, we are simply checking if our direction is equal to -1. That means the player is facing towards left direction. And what we are doing, we are simply dashing in the left direction. How we are doing, I have again created a subgraph for it. In the subgraph, we are simply setting the player's velocity in this way where vector2 dot get left, which means or which denotes -1 and 0. That means -1 in the x direction and 0 in the y direction. And we are simply multiplying it with the dash speed variable that we created over here. So the player will move in the left direction with this velocity. Now, after this, if our player is not facing towards left direction, then we are checking if the player is facing towards the right direction through this logic. We are checking if the directions value is 1. If it is true, then we are dashing to the right direction. And the only change between dash left and dash right is in dash right, we are setting the x value to 1. So this vector2 get right denotes 1, comma 0. Go back, and that's it. That's all about the logic. If you found this video useful, then please hit like and subscribe because it would mean a lot to me and will help me in making more useful videos in the future. Thank you, and I'll see you in the next one.